Hello all, this is Vignesh here. Hey everyone, welcome back to Educators Inc., your go to space for clear, concise, and concept driven science education as well as mathematics. In today's episode, we are going to dive deep into one of the most groundbreaking experiments in atomic physics, Rutherford's scattering experiment, and how it led to a revolutionary new model of atom. So let's get started. In 1909, a simple experiment changed how we see the atom forever. Ernest Rutherford and his team fired tiny positively charged alpha particles at a thin sheet of gold foil. Most particles passed through a straight line as if atoms were mostly empty spaces. But few bounced back at a sharp angle that shocked Rutherford. He concluded that atoms must have a tiny, dense, positively charged center called as nucleus. Now we will see the experimental setup for the scattering experiment that Rutherford performed. This is the experimental setup of the Rutherford's scattering experiment. It consists of a lead block containing a radioactive substance from which the alpha particles are emitted. It is passed through a lead plate as shown, and then it is struck on the gold foil from which the atoms are released, which then further strike on the zinc sulfide screen, which appear like a shiny spots as shown in the figure. Now we will see the visual or the demonstration of how this actually works. Now we will see a experimental setup or the demonstration of how the scattering experiment takes place. Now on the screen we can see the experimental setup for the Rutherford's scattering experiment. It consists of a lead block, a gold foil, and a zinc sulfide screen as shown. Now, if I play the play button, you can see that the alpha particles are emitted from the radioactive element placed in the lead box, striking the gold foil, and the particles are emitted from the gold foil in a straight line, and some of the particles are deflected in different angles, and they strike on the zinc sulfide screen as shown in the figure. Now we will see what did Rutherford observe by after performing this experiment. Now we will see what did Rutherford observe after performing this experiment. The observations that are made by Rutherford led him to conclude that a major fraction of alpha particles bombarded towards the gold sheet passed through the sheet without any deflection. Now, when I showed the demonstration, you must have seen some particles move in a straight line without any deflection, and hence most of the space in an atom is empty. Some of the alpha particles were deflected by the gold sheet by very small angles. You have seen some particles deflected in different angles. Hence, the positive charge in an atom is not uniformly distributed. The positive charge in an atom is concentrated in a very small volume. Very few of the alpha particles were deflected back. That is only a few alpha particles had nearly 180-degree angle of deflection. So, so the volume occupied by the positively charged particles in an atom is very small as compared to the total volume of an atom. Hence, we conclude this video. In the next video, we shall see the actual postulates of the Rutherford's atomic model and its limitations. Please like, share my video and subscribe to my channel by clicking on bell icon. Thank you.